Hello, my name is Ryan Nienhuis. I'm a product manager for Amazon Kinesis, and today we're going to talk about building a data streaming application leveraging Apache Flink. So we'll go through three main learning objectives today. First, we're going to talk about the business benefits of adopting streaming applications. The why. Why do companies adopt these technologies? And then the next thing we'll talk about, why do companies choose Apache Flink specifically? And we'll cover some what Apache Flink is and its various capabilities, as well as how to implement some best practices using Apache Flink. Finally, we'll talk about seeing how to maintain real-time applications over time with low effort and resourcing needs. So the volume of data being produced is ever increasing. And this is from the advent of Internet of Things to cloud computing, as well as internet connectivity. The amount of data that you yourself produce, as well as companies collect, has increased considerably. 90% of the data in this world was generated in the last 2 years, and that continues to occur. This data is produced at a high volume continuously and at a high velocity, meaning that it increasingly is created very, very quickly, as well as just in a large amount of events, a large amount of variety. And that variety comes from a large number of data sources. I mentioned a couple previously, like Internet of Things, but it comes from your web clients and mobile clients, mobile apps, including games, business productivity software, application logs, usage or customer event records or metering records, and then connective things like smart buildings, smart cars, smart devices. So all of these large variety of sources are producing data at a high volume as well as at a high velocity. So to get value from this data, companies must both handle all of these V's, the variety of data sources, as well as capturing data at a high velocity and volume. And the tools they typically use to do this are data warehouses and data lakes. So ingesting and then processing data on a data lake, analyzing it, and/or in a more structured manner in a data warehouse. Companies need to make timely decisions on all of this data using these tools because data loses value quickly over time. So finding out that a customer is having trouble with your product right now is much more valuable than finding out a customer has churned away from your product or platform after the fact. Your last monthly business report is much more valuable than the business report that was generated 12 months ago. So the information is more valuable when it's delivered in a timely manner because it allows you to make timely business critical decisions. So data streams enable you to make and derive those insights faster and sometimes in real time. They work with data warehouses and data lakes in order for you to continuously capture, process, and analyze data in real time so that you and your business can make those timely decisions. And the focus of today's talk is going to be about how to use Apache Flink to get those real-time insights. Let's go through a customer example real quick, just to make this more concrete. So Autodesk is a company that delivers software that helps builders build. They do everything from automated computer-aided design to simulation software, and they run a set of services, cloud-based services, in a piece of software called Autodesk Forge that allow customers to build the best possible things for your customers, everything from cars to video games to buildings. So in order to monitor those services that provide that rich experience for engineers, Autodesk built a unified log analytics solution with both real-time analytics and data lake components. So they ingest application logs, one of the variety of data that I mentioned, at a high velocity and high volume to generate a single pane of glass that gives their engineers visibility to make sure that they're giving the best customer experience. So when an engineer using, say, AutoCAD software asks a question of, why isn't my simulation working correctly, or why is it taking so long? Their team is aware of it and addressing the issue immediately. So let's go through some common use cases and just provide an overview of AWS services that we offer customers to make streaming data easy to use. So when we talk about real-time or data streaming use cases, generally customers tend to gravitate toward the use cases that are generated in the milliseconds or even faster. This is responding to data as it happens. It's messaging between microservices. However, when we talk about getting timely insights, it's really a spectrum. So customers might be simply delivering their data to their data lakes and data warehouse faster than they did previously. So they might be using streaming technologies to get data to those data stores in minutes instead of hours or days. Also in a fashion that's where they're able to process it immediately after it arrives to the data lake, instead of performing a number of other steps after the fact to just massage and clean up the data. So at the simplest use case, that's in the latency of the minutes, and that's a core streaming use case. However, as companies strive to get those more timely insights, they've pushed in this faster to the seconds and milliseconds latency. So when we talk about seconds, we're talking about log ingestions, monitoring like preventative maintenance or reactive maintenance for IoT devices, so monitoring sensors, change data capture use cases where they need to publish the result of a change in a specific database to a lot of different internal services, to even faster, like responsive analytics with machine learning. So running machine learning on the data close to when it was generated, and so in order to improve the recommendations customers give on a retail website, or offer a better in-app gaming experience for customers. So very quickly, for those who are unfamiliar with streaming data, what does a typical architecture look like at the very highest level, the 1,000-mile view? So at the edges, we have a set of data sources that are producing that data from a large variety of sources, the large variety of types, at a high volume and velocity. And that when the destinations on the other side is where the data actually lands. And I like to think of that as where it stops moving. So customers generate this data. They need some mechanism to ingest the data and then store it. So I'll cover two stream storage technology services that AWS offers. But after the data is ingested and stored, the primary mechanism there is durably captured. So these IoT devices or servers, they typically are transient and they don't provide that durable storage. So the first sort of mission is to get the data off of those data sources quickly and efficiently and durably store it. And that's what streaming storage provides. And then it makes it available to customers to process using a stream processing tool in real time. So we're talking about sub-second, in the millisecond level latencies, all right? So the focus of the conversation will be on stream processing, but we'll cover stream storage. Stream processing is where the value is derived around insights. So it's where you turn that raw data into information. And then you usually either react to it in real time or send it to a destination. So the first service I'll cover is a streaming storage technology is Amazon Kinesis Data Stream, which provides the ability for customers to easily capture, store, and then process real-time streaming data. It offers the way you interact with the service is you create a stream, and then you set up your data producers to write to that data stream. And then you have one or more data consumers read from that data stream. The fundamental thing that Kinesis Data Stream provides is it decouples data producers to data consumers, and it provides a scalable, easy administration, and low-cost way to ingest a very large amount of volume data at low latency. There's a lot of options for processing data off of a stream, everything from running custom libraries on Amazon EC2 to fully managed services like AWS Lambda. Amazon Managed Streaming for Kafka is another storage solution that we have, or service we have on AWS, which offers a fully compatible, fully managed service for running Apache Kafka, a popular open source streaming data software. The Amazon Managed Streaming for Kafka allows you to remove the operational overhead associated with managing your Kafka cluster. It's highly available and comes with everything you expect from an AWS service, with the security and deep integrations with AWS. So those are two options for streaming storage. I give you that context because it's going to come up as we bring up the stream processing, because they kind of go in hand to hand. You have the storage layer, which is primarily associated with capture, durable storage, and then making it available to the processing layer. So Amazon Kinesis Data Analytics is a service that allows you to easily process and analyze streaming data in real time. You can consume data from Amazon Kinesis data streams or Kinesis data files, process it using your code, and then write it to any destination. We provide two language support, both SQL and Java. And Java is powered by an open source framework called Apache Flink, which we're going to cover in depth in the next 10 or so slides. It allows you to build a fully managed and elastic stream processing application without any servers, and takes care of all the infrastructure required to do things like manage state, as well as automatically scale, so on and so forth. So let's talk about Amazon Kinesis Data Analytics and Apache Flink. So Amazon Kinesis Data Analytics for Java is powered by Apache Flink, and it has a set of characteristics that are important to a stream processing application. So first of all is that real-time processing. So you can do everything from sub 1 second processing to minute level buffering and ETL that you'd expect for, say, a streaming ETL use case like I mentioned previously. It's very easy to use. You can set up a POC in minutes, and it uses open source libraries. It's well integrated with AWS, and it provides automatic elasticity. So Java applications Kinesis Data Analytics work with 3 easy steps. So the first thing is you build a Java application in the IDE of your choice using Apache Flink. Apache Flink is a distributed processing framework and engine for processing data streams. Once you build your application using Apache Flink, you'll upload your application code, essentially a jar, to Amazon S3 or directly to the service, and then run your application in a fully managed service. So that's kind of what your dev cycle looks like. So you're going to build locally. Once you get it running locally and tested locally, you'll then upload your application to make sure that it runs well in the service, and then run it. So why Apache Flink? So first of all, why did we, Amazon Kinesis Data Analytics, choose to use Apache Flink as the underlying framework to power its Java application? So first and foremost is it provides a simple programming model for you to build streaming applications. You build applications using concepts called data streams and operators, and connect them together to build a simple application. You can think of your application as almost a streaming graph or a streaming flow, where you connect one logical step to another logical step. And it abstracts the underlying infrastructure from you, enabling you to focus primarily on your logic when you build the application. This enables you to reduce your application build times from, say, 3 months, say, for a moderately complex application, to under a month because of these simple programming applications, where you have to worry more about your specific business logic and not very common stream processing things like doing things like partition or reordering and things like that. We'll cover that in more detail in a later slide. It's very highly performant. It offers in-memory computation with low latency and high throughput. And what do we mean by high throughput? So when you're processing data streams, I mentioned high volume in the beginning of the presentation. And typically, this could be anywhere from, say, a couple events per second to hundreds of millions of events per second. And Apache Flink can handle that type of performance, doing relatively complex things like even machine learning, real-time analytics like sums and counts over windowed aggregations, everything like that with a large, high variety of data. That's another reason why we've chosen Apache. It offers stateful processing with 2 mechanisms to back up your state in case anything happens to your application. When we talk about stateful processing in the context of stream processing, we're talking about as events or pieces of data flow through the stream. One event that you're processing now will either be correlated or be dependent upon the processing of an event that occurs in the future or the past. So the events are relate to each other in some way. The simplest way to think about this is if you're buffering a small record into a larger file, say into larger files to be written to Amazon S3, that could be an example of stateful processing. To much more complex use cases like machine learning on the stream, where you're keeping up to model state. And Flink provides mechanisms to back up that state, both incrementally as periodically, so that if anything happens to your application, you can maintain strong data integrity. So exactly once processing or consistent state. There's different types of processing semantics provided in stream processing. The most common are at least once and exactly once. When we say at least once, it means that the processing framework is guaranteed to process every record in the stream at least once with no data loss. So this means that there might be duplicates associated with your processing, but there certainly aren't, there's no data loss. When we say exactly once processing, again, it still has the characteristics of no duplicates, but this also guarantees that the result of the application at the eventual destination only impacts the result once, and then it provides idempotent processing at the destination. And an idempotent result or write to the destination. When we talk about exactly once, that's what Apache Flink provides. And it does this out of the box without you having to worry about anything, without having to build this into your application yourself. So we mentioned when you build an application, you use a set of data streams and operators. A data stream is the structure you program against, and the operator is what you'd use to transform the data stream. So as data flows in, it's represented as a data stream, and you apply one-to-many operators on that incoming data stream. So a couple of the categorizations of operators are shown below. They're everything from very simple, like a map, which takes one element and produces another element, to much more complex things like windowing, like performing aggregations over a time window or over some other different defined window. But basically, where you're able to define the beginning and end of processing. All these operators replace hundreds of lines or even more of code that you'd have to write yourself. And they implement those best practices that I've mentioned in the previous slide. They're all highly performant, they support exactly once processing, and all of their state in their processing is backed up with periodically and incrementally. The most important operators to call out here, aside from the most basic ones like map, are key by, which allows you to partition a stream by a specific key. So as an example, you might be reading a data stream from Amazon Kinesis Data Streams, and say you're writing IoT data to that data stream. You might want to organize processing by a specific sensor ID or even a sensor type. You can specify that in your key by, and then all data associated with that key will be sent to the other downstream processing. This allows you to improve the efficiency of your application, as well as just allows you to perform different types of analytics, such as group bys or windows. The out-of-the-box analytics functions include sum, min, max, and much, much more. These are very, very simple analytics functions that are available to you via the data stream API. Apache Flink also includes other higher-level APIs, including the table API and SQL-based APIs that are built into the Java processing. So you can, if you want to do some abstracted processing, you're able to do so as well, beyond just these operators. Essentially, I'm saying we're just scratching the surface of the types of operators that enable you to quickly build an application. So what would a simple application look like? So imagine on the ends, the streaming storage and the destinations. You have Amazon Kinesis Data Streams, which is capturing those IoT device data. There's maybe it's sensor data as an example, and then eventually getting the data to Amazon S3 and DynamoDB. So you might first you have the data source, which is associated with the data stream. You might apply a very simple apply operator, which just does a small transform on the incoming data. On the top, you might have a key by that organizes the data by that sensor ID, and then a window, right, which produces a keyed data stream. Another type of specialized data stream that is associated with that key that I brought up. And that window might perform some aggregation function. So perhaps you're performing some real-time analytics, like counting the number of sensor IDs, unique sensor IDs, or maybe counting the number of events per unique sensor ID. This can be done using a key by and a window operator. After that, the result is written to Amazon S3 in a periodic fashion in larger files, so that your downstream processing can handle, can more easily process it. So you're doing some data prep as well. On the bottom, I have another operator, like a simple filter, which results in a data stream and a sync to DynamoDB. The point that I'm illustrating here is your streaming graph or your application can build almost a pipeline of different steps, both in serial and parallel, to build your streaming application designed for your specific use case. So what does simple code look like? I mean, there's a lot of missing pieces here, but I've tried to isolate it down to just the core part of the application. So we have, we're adding a source, which is a new Kinesis stream, which is a set of input events. We're then mapping those events and then performing a key by and window function and maybe some apply where you have some of your custom processing. Finally, we're taking the output of that processing and then we're sending it to another Kinesis data stream. or you might have another application, or you might use a different type of tool, perhaps AWS Lambda to perform some other types of processing. The point here is that like some of these would represent anywhere between 20, 30, even more hundreds of lines of code. In fact, the key by operator is thousands of lines of code if you would have to do that yourself. But this is replaced by a single one-line key by operator. So Apache Flink, as well as Kinesis Data Analytics, provides extensible integrations with AWS services and the open source ecosystem. So sources include Amazon Kinesis Data Streams and Apache Kafka, as well as RabbitMQ. And you can send your results relatively easily to Amazon S3, Elasticsearch, Apache Cassandra, another Amazon Kinesis data stream. And this is just a sample of the data source. The community is adding more, the Apache Flink community is adding more sources with every release. If these sources or destinations don't work with you, just like operators, as well as sources and sinks, you can extend them in Apache Flink. So if there's a source or destination that's not listed here, you can build your own. The framework is easily extensible to meet your needs if something out of the box doesn't work to your specification. So Amazon Kinesis Data Analytics provides a monitoring tools that are based on Apache Flink monitoring tools to help you debug your application as well as identify a problem. So the first thing is metrics associated with it and logs associated with it that are at different levels: the application, task, operator, and parallelism. So at the application level, you get a couple metrics and some high-level information about how the application is doing, whether it's running correctly or not running correctly. And at the parallelism level, you get the very specific information about what is essentially every thread that's in the application, what the data that's going into and out of it, and whether it's running to issues. So very granular monitoring. And these are Apache Flink metrics that we simply surface through a CloudWatch log metrics. If the Amazon Kinesis Data Analytics sends the CloudWatch so that you can more easily monitor, set alarms, and that type of thing. For logging, we offer 4 different levels, from info to error, that allow you to specify either very, very granular logging or a very high level, whether it's just only log the specific error. The other thing that Amazon Kinesis Data Analytics provides is it surfaces the Apache Flink job graph directly in the AWS Management Console. Similar to the slide that I showed previously, which represents a series of operators and data streams connected to build sort of what the logical flow of the application is. This is shown in the AWS Management Console. It's pulled from the Apache Flink, underlying Apache Flink infrastructure. This gives you a visibility of how data is flowing and allows you to contextualize the information associated with your metrics and logs. We mentioned Apache Flink provides both exactly once processing as well as durable application backups. So the two mechanisms that it does that is through checkpoints and save points or snapshots. Let's cover the first one first. Checkpoints are while an application is running, an Amazon Kinesis Data Analytics application is running, it allows you to automatically, incrementally back up your application. So if anything that were to occur that's more of a transient failure, like a node goes down, or you have a slight disruption in your application, or a recoverable error, it allows you to restore your application without losing any data, without producing any duplicates, relatively quickly. Alternatively, Flink has a mechanism called SavePoint that we expose to them as a snapshot that's kind of similar to like what you would think of an EBS snapshot would be, in that it is a point-in-time recovery point for your application. So you can create these at any time. We also, Amazon Kinesis Data Analytics automatically creates these when you update your application. So if you update your code and you run into an issue later, you might find a bug, several hours or even days later, you can roll your application back to the previous point in time with the exact same state that when you took the snapshot. We have an API that we expose where you can easily create, as well as delete, as well as restore from snapshots to make this easy. So customers often do this maybe once a day, but the customers that would like to more frequent rollout times, maybe they do this once an hour. Both mechanisms provide both a way to handle failures with checkpoints, as well as a way to roll back your application to previous point if you have discover errors later. So application scaling, and I alluded to this a little bit when we brought up monitoring or parallelism. But the way scaling works within Amazon Kinesis Data Analytics, it builds upon some core Apache Flink constructs, notably parallelism on the right-hand side. This describes sort of the number of instances per task. So if you have a key by operator and you set it to a specific parallelism of, say, 10, that's the number of instances of that operator running. You can set the deparallelism at the application level, so overall, which is passed down to all the individual operators, or do this at a fine-grained level. So if you have one operator, one step in your application that is more computationally intensive or more memory intensive than a specific than the rest of the application, you can set that to a higher level of parallelism. It allows you to do that. This is an important characteristic because the combination of the key by operator as well as being able to set operator parallelism allows you to scale out independent steps of your application relatively easily without hitting another storage link. On the resources that we define within the service itself is we associate a specific unit of compute and memory with each unit of parallelism. We call this unit a Kinesis processing unit, and it represents 1 vPCU and 4 gigabytes of memory, as well as 50 gigabytes of running application storage, so local disk. By default, we map one resource or one KPU to one unit of parallelism. However, you can change this from 1 to 8, so meaning that we can assign 8 parallelism to a single KPU. So using either the default or increasing that higher, you can run the application either in automatic or provisioned way. So you can still set the parallelism yourself for specific for the overall application or as well as specific operators, or you can let us automatically scale you up and down. An example of when you wanted to increase the parallelism for a specific KPU for that mapping, as an example, would be typically high I/O applications require a higher ratio of parallelism to resources. If you have more computationally intensive steps, then you want to keep it lower, perhaps at the default. So you, with Apache Flink, you have granular control over an application scale, and you can allow Amazon Kinesis Data Analytics to either automatically do it for you or simplify how you provision your infrastructure. So instead of maintaining clusters and things like that, you simply tell us how much compute and how much parallelism you want, and we'll spin it up for you. So Amazon Kinesis Data Analytics charges on 3 primary dimensions, and I'll cover this relatively quickly. The first is on KPUs. So 1 KPU is added for orchestration, and beyond that, for what it takes to process your the data in your incoming application, we charge 11 cents per KU hour in the US East 1. KPU hour in US East 1. We also charge 10 cents per gigabyte month of running application storage and 2.3 cents of durable application backup. More than 90% of your cost is likely going to be associated with the Kinesis processing unit, or KPU. Depending on your workload, the storage and backups will be a much smaller portion. And for the vast majority of customers, backups is a rounding error in the bill, just because of this is a mechanism we use for your as the safety mechanism. So we don't want you to ever have to worry about charge when you decide whether or not to take a snapshot and store this in durable application. So let's go through some short and simple best practices for building and running applications using Apache Flink and Amazon Kinesis Data Analytics. So we're not going to go into too much depth, but these are just some nice things to keep in mind when you get started. So the first and foremost thing that we bring up is that we see it often when you're running an Apache Flink application within Kinesis is the inclusion of local dependencies. So you might have something as it work well when it's built and run locally within your IDE, and then you upload it to the service and it no longer runs correctly. And one of the most common reasons that we see this is with dependencies. But it's a much broader issue with you're running it in a managed environment instead of the IDE. So the first thing we recommend is make sure you have checked all your dependencies, whether they're there. And then we have the CloudWatch logging feature that we have. Make sure that you check that and increase the granularity of logging if necessary, if you're not getting the information you need. Next thing is a very commonly talked about stream processing concept of processing versus event time. And when we say processing versus event time, we in stream processing, when you're building windows on continuously captured and processed data streams, you have to define a beginning and end to that window. And that usually is defined using some time semantic. And the most common, two of the most common are processing versus event time. Processing time refers to the using the actual like system clock of the nodes that are underlying infrastructure that's processing your data to define a start and end time for your aggregation. So if you're summing something over, say, a 1 minute window, we'll use the clock on the underlying infrastructure that's processing the data to do that. The great thing about processing times is it's nice and consistent. However, it's usually not what you want when you're processing data on data streams. Usually you want event time. The event time is the actual timestamp included on the data that's being processed. It has a logical meaning to your business and your applications. So most companies want to end up using event time, which Apache Flink supports. There are some complications with using event time. A simplest example I could bring up with this is when you have a data sources with vastly different time semantics. So perhaps you've got clock skew that's really, really large between different IoT devices, or an inability to have accurate clocks on devices. So sometimes customers want to use a combination of processing event and event time to provide consistent triggering of data. So when you're going to send the result downstream, with the combination of using event time as a logical key, just using a combination of both. So this is a very deep topic, but this is something to consider as you build a stream processing application. So more simple best practices for testing and running applications. So first, when you're using Kinesis Data Analytics, an application has a state associated with it, creating, running, updating, that type of thing. The most important thing to check if you believe there's issues with your application, first and foremost, is that application state. Is it updating? Is it running? That type of thing. That'll tell you whether the application's in a normal state or not. If we were to recommend to set one alarm on your application, we'd recommend setting an alarm on millis behind latency. When you're processing streaming data, you want to make sure your application is keeping up with the most recent data that's in the data stream, the underlying stream storage. This most recent data, this is how you make sure that your application is real-time, getting those timely insights. The metric that we emit for that is to monitor that, to make sure that application is processing the latest data, is milliseconds or millis behind latest. This refers to how far from the latest data that the streaming storage has is my application running. And for most applications, customers want this under a minute. For more latency-sensitive applications, you want it even under a second or even a couple of seconds. But you want to make sure that you alarm on that so that it gives you an indication that you're no longer getting those timely insights. So if there's downstream systems that are depending upon your application processing data at a certain latency, this will be one of the simplest ways to tell you that's a problem. It's not the ultimate metric. It's not doesn't tell you everything that's going wrong with processing, but it does provide a pretty good mechanism. Before you move into production, there's a great list of sort of production readiness checklist on the Apache Flink documentation. The only other thing that we'd say is that make sure that you very thoroughly test application updates and restarts and restoring from safe points. So this is for Kinesis Data Analytics. This is making sure that you are able to sustain an application update and for your application to recover gracefully within this time frame based off your requirements. And then also make sure that you test restoring from a safe point. So restoring from that periodic backup. So again, these are some very simple best practices for you to get running using your application. So thank you very much for attending the webinar today. Hopefully you learned something at a high level about the value of stream data processing, and this introduction to Apache Flink hopefully was useful to you. You can learn more on the Amazon website and on the Amazon Kinesis websites. And with that, I think we'll start with questions.